In this video, we are going to talk about some concept. For example, in this video, we are covering the class 12th wave optics, and in wave optics, we will cover some principles like Huygens principle, which is fundamental in wave optics, and then we will cover other topics also, for example, interference, diffraction, and Huygens principle related reflection and refraction, and other principles like that. So let's get started. In this video, we are going to cover wave optics with help of the uh, this PDF will provide you some notes, and in this concept we have created some non-linear notes for you, and you can take advantage of both of them, and I will give them in description box. So in this video we are going to cover the most important topic of wave optics, which is Huygens principle. So Huygens principle, so our main structure is, first we have a problem, and then we create a scenario through which you have a problem and you have to solve it by the information and the knowledge I am giving to you. And in this way, the knowledge will stick to you more. So the thing is that we know that refraction and reflection exist, but the problem is that we don't know why this exists. In optics, they exist like a law, but not really we know their reason. So to know their reason, we have to go into the wave optics and learn about the Huygens principle, so we know why the reflection and refraction happens. So first of all, we have to know about, before jumping into the Huygens principle, first of all, we have to know two things. First is wavefront and second is wavelets. So wavefronts are the imaginary line which joins all the points of light which are in same phase. They are large, and wavelets are the secondary waves which are created by the points, each individual point, and they are small. So this is the difference between wavefronts and wavelets. Difference between the So now we know the difference between wavefront and wavelet. We can jump into the definition of Huygens principle. So the Huygens principle is states that the every point on a wavefront is in itself the source of spherical wavelet. So each and every point is itself a source, and it creates a spherical wavelet. Wavelet is what is wavelet? Wavelet is a secondary wave. Okay, and it is spread out only in forward direction. So the wavelet spread out only in forward direction, and after moving forward, the sum of the spherical wavelets form the wavefront. So now we will understand it with the help of animation. So this is the wavefront, and there we can see that these points are imaginarily connected, so it create wavefront. Okay, now the wavefront are going forward in forward direction. Okay, and we can understand the wavefront by the example of a water body in which we put a drop and it begins to ripple, and that rippling creates the wavefront. And this is the 3D view of wavefront. Wavefront shape depends upon the source. If there is point source, it will be spherical wavefront. If there is a cylindrical source, then there will be a cylindrical wavefront. And if the source is very far, then it will create a plane wavefront. Okay, so sun is very far, so it will create a plane wavefront. Huygens principle states that the These are individual points and they create the wavelets. Okay, so individual points create the wavelets, and these are secondary wavelets. So these wavelets, when they uh, they are produced, and if we join their tangent, then it will create a secondary wavefront. Okay, so now you have understood about Huygens principle. We will move forward. So now let's learn about how the refraction happen in denser medium and in rarer medium. So to prove the it happen in denser medium and in rarer medium, so this is a plane wavefront which is falling on a denser medium. So first we will talk about denser medium, then we will talk about rarer medium. So first the angle of incidence is angle I, and there is angle of refraction which is angle R. Now the light first touches the medium, so in there the speed of light will be v2 and it will be less, and in there will the speed of light is v1. Now we know from the trigonometry you have learned. If you don't know, then I will revise it. So if there is an angle, let's say I, so sine theta, sine I is equal to perpendicular upon hypotenuse. So this is perpendicular side which is opposite to the angle, and this is hypotenuse. So sine I is equal to perpendicular upon hypotenuse. So there will be BC upon hypotenuse is AC. So BC upon AC. So sine I is equal to BC upon AC. Now let's say there is an angle R. So for this, sine R is equal to AE upon AC. So sine R is equal to AE upon AC. Now we know that sine, if we divide sine I and sine R, then it will be sine BC upon AE. Okay, because AC and AC will be cut. Now the BC is V1T and AE is equal to V2T. So T will be cut at V1 upon V2. Now we know that N1 is equal to C upon V1 and N2 is equal to C upon V2. So the V1 upon V2 will be opposite of it, it will be N2 upon N1. So the refractive index, so sine I upon sine R is equal to N2 1, and this is Snell's law. Okay. Next thing is the refraction in rarer medium. So in refraction in rare medium, we will say that similarly, and the n1 sine I is equal to n2 sine r in this also. But in extra thing we have to learn here is that the sine for critical angle, the angle of refraction will be 90 degree, and if this angle of refraction will be 90 degree, then it will create the I critical angle. So in angle of incident will be critical angle, and for 90 degree sine R will be I. So the sine I C is equal to n2 upon n1. So we can say that the refractive index is equal to the sine of critical angle. Okay, angle of incidence. So if the angle of incidence will be greater than the critical angle, then there will be total internal reflection. So total internal reflection is when we put a light through a denser medium, and it will not refract, but it will get reflected. Okay, so it will get reflected. It is called total internal refraction. It only happens if the angle of incident is greater than 90 degree. Okay, if angle of incidence is greater than critical angle. Okay, so now we have completed the Huygens principle. So let's us look at the disadvantage of it. So what are the disadvantages of Huygens principle? So concept, it cannot explain the concept of emission of light, absorption of light, and polarization of light. And the Huygens principle has failed to explain photoelectric effect. So these are two things that Huygens principle are disadvantages at. First thing is that it cannot explain how the light is emitted. Second, it cannot explain how it is absorbed. And third thing is it cannot explain polarization. Polarization, if you don't understand it by now, so polarization is if a source, if a light is oscillating at random direction, so it is unpolarized. If it is oscillating in one direction, then it is polarized. Okay, so for now, understand polarization like this. And photoelectric effect, what is photoelectric effect? So photoelectric effect is an effect where a certain frequency wave light can emit an electron, but others, or the certain wavelength light can emit an electron, but and there, it is discovered by the Albert Einstein. We will discuss about it later. And next, we have coherent light. So what is coherent light? And so first of all, we have to create some problem to make the context of the coherent light. So the context is that there is a light. It goes through two slits, and after going through these slits, we saw some pattern where there is a dark somewhere and there is light somewhere. So it is created by a source, and a source, it is not created by any source. It requires a specific source of light, so we can create this pattern. So for creating this pattern, we have to understand the types of sources. So there are two types: coherent or incoherent source. And now we will study about these sources. Okay, so coherent light is a light whose photon oscillate at same frequency and whose wavelength are in phase. So first, coherent light is what? What is coherent light? So coherent light is photons are oscillating, and their frequency should be same. Or next, wavelength should be in phase. Wavelength, same phase. Okay. In incoherent light, the photons of incoherent light oscillate at different frequency and their wavelengths are not in phase with each other. For example, in this figure, you can see that the frequencies are not same and they are uh, at different frequency and wavelength are at different phase. But this is an example of coherent light source where they are going simultaneously up and down, and this is a type of coherent light. So if it have same uh, frequency and the wavelength are in same phase. Okay, now let's talk about the uh, Young's double slit experiment. Uh, it is affecting the our understanding of interference. So in double slit experiment, as we have seen that a single coherent source of light is producing some patterns in there where we can see that there is some darkness over there and then some brightness over here. So it is due to constructive and destructive interference. So basically interference is when the two lights get waves can overlap. So in constructive interference, the two waves get overlapped and it create a big wave. And in destructive interference, the two waves in very opposite direction get which are not in a phase get overlapped and it will create complete darkness, and due to which we can see some dark pattern over there. Okay, so let's go and check the definition of the interference. So interference is a phenomenon in which two and more waves are superposed to form a resultant greater, lower, or same amplitude. So we can see that in interference there is waves are superimposed, and due to which it create a resultant wave which is either greater, either lower, or same amplitude. For example, we can see if we can imagine it as water, then we have two slits and we push water through it. So some where we can see that it is greater of amplitude than the previous, and where we can see the lower amplitude and somewhere we can see the same amplitude. And in constructive and destructive interference, in constructive interference the waves are in same phase, and so the resultant wave get amplified. And in destructive interference the uh, waves are in opposite are completely opposite and out of phase, so it create distortion, and there is no amplitude or low amplitude which create darkness. So let us see the definition of constructive interference. When the two waves travel in the same direction and are in same phase with each other, and their amplitude gets added and the resultant wave is obtained here, the waves said to have undergone the constructive interference. So constructive interference is where the two waves travel in same direction and are in phase with each other and their amplitudes get added. So the resultant obtained is gone through constructive interference. In destructive interference, the interference takes place when in any location where the medium, when the two waves interfere with each other, have a displacement in opposite direction. So, if one wave is out of phase or completely out of phase and have displacement in opposite direction, for example, the crust is met with through, and through is met with crust, so it create a destructive interference. Now we have another experiment over there in which we, through a small hole, we put some lights and we see a pattern where we expect some shadow over there, and we can see light at the unexpected areas, and we can see shadows at some other expected areas in unexpected areas. So this experiment can be explained by the diffraction. So what is diffraction? So diffraction is uh, of light is defined as bending of light around the corner, such it spread out and illuminate areas where a shadow is expected. So it is like a light. So light is a type of wave. So when we put a wave through a small little hole, then we can see that it get bent and interfere with itself, and due to which we can see some pattern like this, where there is large intensity at the middle where we expect light, but the decreasing intensity of light mm, as we go farther away from that main point. Okay. Now, what is the difference between diffraction and interference? So the Young's double slit separation gives equally separated fringes. So in double slit experiment, we got the equally separated fringes. So interference create equally separated fringes, but in the interference we have the width of different intensity. So a single slit of width gives a diffraction pattern with central maximum. So there is maximum at center pattern, and the intensity falls to zero with decrease of pi upon a. So there is a decrease of intensity of lambda upon a. So it will get successively weaker secondary maxima in between. So thank you for being here, and thank you for watching this video.